Okay, now I'm going to attempt to explain a topic that is not central to our discussion, but is a really interesting feature of Python and really of any language, and that's the idea of forking a process. Now, this is a particularly thorny topic to cover because it involves imagining that you're actually running more than one program at a time. And so it's also going to be a challenge to describe it to you, but I'm going to give it a shot. When we talk about forking, we're talking about spawning a duplicate process. What does it mean to spawn a duplicate process? Well, first off, what is a process? A process is a running program. So anytime you run any program at all, we can call that a process. For example, your Python program, Windows, not Windows, let's say, Excel, the Word, Grand Theft Auto, any sort of program that you might run on your operating system, when it's running, when it's a program that's running, we call that a process. And in fact, with many programs, it's possible to run multiple copies of the same program at the same time. That's when we can say we've got a duplicate process. That is, the process is a running sort of copy of the program. So it might be possible, if it weren't prohibited by the program itself, to just run 3 copies of Word at the exact same time. There's no reason why that shouldn't be possible with any given program, to run the same program multiple times. You could even try it with your own Python scripts. You could run, as long as you can make it so that it doesn't return right away, you could run 3 copies of your program, and it would create 3 running processes that run alongside of one another of your program. Your program doesn't need to be run only once. It can be run multiple times simultaneously. Now, when we talk about forking, what we're talking about is having our program duplicate itself and run a duplicate copy of itself at the same time that the original is running. Now, this is one of the things that makes it so challenging to explain, and it'd be great if I had a little diagram here, but I don't. Your program can duplicate itself while it's running. And while it's running, duplicating itself, it can create any number of additional processes of the same running program that run from the point that it duplicated itself. Again, this is really tough to describe, but you need to imagine that your program is running, and at some point it says, I'm going to fork myself. I'm going to fork myself and have an additional running program run alongside me. Now, why would you do that? The reason you would do it is if your program needed to maybe execute a very time-consuming process. Maybe it needs to crunch a bunch of numbers. Maybe it needs to execute a really long-running SQL query. Maybe it needs to send a bunch of emails. Whatever it needs to do, if your process needs to take care of something that's very time-consuming, but it would also like to keep running and keep doing other things as well, you can have your program fork a process and send that process off to go do the time-consuming task. It's almost like generating a doppelganger. Yeah, I'm sure we've all wanted to have maybe additional copies of ourselves running around doing different things that we feel we don't have time for. Wouldn't it be great to be able to just suddenly duplicate yourself and say, here, go mail these letters or go to the post office to pick this thing up? Yeah, that would be great. Fortunately, we can actually do that with our running program. And we do that through forking. Now, in order to fork, we use a library called multiprocessing. Multiprocessing simply means we're going to run multiple processes at the same time. That's why it's called multiprocessing. And when we import the process class, what we're doing is allowing ourselves to get ready to fork our process. Now, I'm importing some other modules as well because I want to get some stuff done here. Now, let's look at the main body of our program. Don't worry about the if name equals main. I'm not sure if I need that there, but we're just going to use that just in case. What we're doing in that if statement is just saying I'm only running this program. We don't have to worry about that at all. All right, now, when we have a program that forks itself, what we have is a parent-child relationship. The parent process is the process that does the forking. The child process is the process that got spawned by the parent. We use the word spawn, almost like giving birth, right? You're creating a new process out of yourself. So let's look at this code. We begin by establishing a list. We're going to loop through 3 iterations. So I'm ranging through 3 iterations, and I then create a process. Now, what that process object is it's basically getting ready to spawn the process or fork the process. We then use p.start. At this point, a child is created. Now, what we're doing is we're appending that process object to a list, and we don't even need to think too much about that. Now, what we're doing with target and args is that with target, what we're doing is we're setting up a function that's going to get called when the process gets started. And we'll look at that function in a moment. The other thing we're doing is passing a series of arguments. This is a one-item tuple, which will get passed to the function when it does get called. So this process object is really the potential for starting a new process. It hasn't started yet, but it is defining what will happen when the child process is started. Now, once we say p.start, that is, we call the start method on the process, that means that the child process has been spawned and it will now do its work. Now, I want you to imagine that at the point that we say p.start, what we're saying is create a new process on the operating system, a brand new process on the operating system, and run it with the same environment, the same variables, and everything else that is going on currently with this process. In other words, we started our Python program. That's the first process. That's the parent process. That Python program is just like every other Python program. In other words, anytime you ran a Python program, you started a process. So we've begun with our major process. We'll talk about info in a moment, but we see parent process here. We're printing parent process. Then we're looping through, and we're going to 3 times create a process object and get that process object to get started. That means that a new program gets started on the operating system, and that new program is running. Now, because we basically registered a function with that process, we're now going to go and look to see what happens once we get that process started. Basically, when we call the function, and this is a little bit distributed, so it's not really that easy to understand. But basically, once that process gets started, a process ID is assigned to the process. Every process has a process ID. And that process ID is going to be used to identify that process in the operating system. In fact, I can show you really quickly using the top utility that there are 381 processes running on my system currently. And that's pretty average. This process ID, the process IDs of the different processes are listed. You see PID there in the lower left? What we're seeing is basically the dynamics of a running operating system. the operating system is running a whole host of processes. In fact, currently there are only 4 or 3 running processes running at the same time. I'm not sure what stuck means. Sleeping means it's just sitting around. Threads we won't be able to go into. But the idea is that there are 381 processes that are running. 4 are actually running, 376 are sleeping. If you look below, you can see a bunch of PIDs. The PIDs are IDs that mention which processes are running. For example, Google Chrome is running on my system right now. That's the Chrome browser, and it's under process ID 9934. Sync defaults, the top process which I just ran, has a process ID. So keep with me here. When I run a program, that program is known as a process. That running process has a process ID. And when I call start on a process object, it spawns a child process. That child process has a process ID. Oh, I'm sorry. Yeah. That child process has a process ID. I think child num may actually be, oh yeah, that's it. It's the argument that I passed, which is num, and num came from range. So range is going to be 0, 1, and 2. I'm going to start my first child process calling the f function with the current ID that I have here. That's what child num is. That's going to be 0, 1, or 2. What I'm doing here is I'm sleeping a random number of seconds between 3 and 7 seconds because the idea is that our child process may take a little while. And when we get to the end of the function, the child process is done running and we can say that the child is concluding. I think I'd better run this program now to show you what's happening. Now, as you can see, it's taking a few seconds to finish, and that's because the child processes were basically pausing for a random number between 3 and 7 seconds. 3 children processes were created. They ran alongside of the parent. It's really kind of hard to see this, but basically what happened was when I ran my Python program, a single process was created and 3 additional child processes were also created, and they ran simultaneous to one another. Child process 0 had a process ID of 9938, and it ran for a certain number of seconds. I think I'd better say how many seconds. Well, you can see at the end actually. Child 0 concluded in 5 seconds, child 1 concluded in 5 seconds, and child 2 concluded in 6 seconds. I can actually make these maybe run at different times, but I'm not going to be able to do that right now. This is obviously a complicated process, and I'm not really going to be able to describe it much more than that, except to say that at the end, we needed to call join to basically allow those child processes to conclude, and then finally allow the parent to conclude. You can see that the parent didn't conclude until after the child processes all concluded. And basically what happened, again, is that the child process started, the parent process started. That's the one that I ran when I ran Python 08 forking. The parent process, that is my Python program, spawned 3 child processes. Those 3 child processes ran and waited for a random number of seconds. And then finally, when they were done, the parent process concluded. I could run this again, and you can see it's going to take a random number of seconds for each one. If I'm lucky, I'll see that because child 0 took 6 seconds and child 1 took 4 seconds and child 2 took 6 seconds, that they came back at a different order from which the order in which they were created. They were created as 0, 1, and 2. But because they slept a different number of seconds, they concluded at different times. This is an indicator that these child processes ran separately. They ran separately and they ran simultaneously. So the reason I see that child 1 concluded before child 0 is because child 1 had only 4 seconds to run, and child 0 and child 2 took 6 seconds. That's because of this random number of sleep seconds that I arbitrarily created. What I'm trying to illustrate here with this program is that it's possible to spawn child processes that run simultaneously with the parent and with each other. Thus, you can divide up a task into separate groupings. You can maybe divide up a task into, blocks of work and have multiple processes run them simultaneously. This can save a lot of time if you've got time-consuming processes. Now, this kind of forking does not make use of multiple cores on your computer's microprocessor. That is the chip that's running your computer, but it is making multiple processes and allowing them to run simultaneously. It may be a long time, if ever, when you actually need this kind of functionality. But when you run into a case where a program needs to wait on a process, for example, an SQL query that takes a long time, a send mail program that takes a long time to send mail, or some other networking process that the program has to wait on, it may be more useful to spawn simultaneous additional processes to keep going while the original process is waiting for it. Very interesting, very exciting feature of really any programming language, allowing you to fork multiple simultaneous processes so you can get your work done faster in some selected cases.